All right, all right. Hey, what is happening, Nigel?
Hi, I'm good. Thanks. How are you?
I'm doing well. All right, everybody. Listen, thank you for tuning in to Dave Cooper Live. Today is going to be an awesome day because we're having a sneak peek to a product that was designed out of a need for the industry for builders. So this is going to be a lot of fun to talk about. And to remind everybody, and Nigel as well, we are live on 3 locations: LinkedIn, YouTube, and Facebook. We would love it if you could hit that like and share button so we can keep continuing the conversation of construction and driving innovation forward in the construction space, because we are last place when it comes to innovation in the global economy of things to be lacking in innovation. It shouldn't be construction, but you guys are going to change some of that today and what's coming out. And I'm looking forward to sharing that story. So please like and share, and also let us know where you're tuning in from. Put it in the comments. This is an interactive conversation. This is your chance to ask Nigel or myself any questions that you want to ask. Keep it clean, though. That's all.
No.
Nigel, why don't you tell us a little bit about who you are? I want everything from birth to today. 5 minutes. You make that happen?
5 minutes. Well, that's easy. So I actually was born and raised in England, in the northeast of England, up the northeast coast, where it's a lot colder and chillier than even here in Pittsburgh. I grew up there, went to college, university in Coventry as, believe it or not, an automotive designer in that field, so industrial design with a focus on automotive. At that point, I basically ended up looking for a job at the end of that period. It was about the mid-'80s, and found a job in GE Plastics over in the Netherlands. So that was only really my second time abroad, but I figured, okay, what the heck, let's go do it. I jumped on that opportunity and spent several years with GE Plastics in the automotive design team there, who worked with a lot of the major manufacturers in Europe, like Ford, Volkswagen, Renault, Italian companies, Fiat, and so forth, working on a lot of different plastic components for them. So dashboards, fenders, seating components, engine components, a lot of that typical kind of plastic design work. And that's where I kind of learned my trade in terms of design and plastics. And after a few years of that, and touring around Europe, I had a kind of a keen eye on the US. I always wanted to move to the US. Actually, always wanted to go to university in the US, but never had the opportunity. So when I got the chance to transfer to GE Plastics headquarters in Pittsfield, Massachusetts, I jumped on that opportunity and joined the team there. And spent several years there, I think about 6 or 7, again, working in all sorts of different industries. And that's when I got kind of interested in housing. I bought a house myself, an old house, loved the idea of renovating it, got interested and excited in that, and started to work in the industry as well with a company called Ibicos, who their partners, actually one of whom I knew from GE Plastics in Europe, and really got into the home building industry and got interested in really solving the problems that the home building industry had at that time. That was back in the late 90s. After a while, I kind of twisted the arms of the partners, Michael Dickens and Mark Tilley, and convinced them to give me a job there, and jumped on board with Ibicos and got involved in all sorts of programs, again, looking at innovation, looking at new opportunities in the industry, ranging from drywall systems, bathroom systems, HVAC, wall systems, and also online training for home builders. We saw a big opportunity there with the precursor to what is now Perform, to really take advantage of the technology that was available in online training and online information, which was just burgeoning as an industry at that point, and building online training courses and really trying to improve the quality of construction in the US, and did that for a few years. Then, of course, the industry tanked, and I stepped away for a while. I worked for the Society of Automotive Engineers, did a little bit more automotive work, but always had contact with the Ibicos folks and jumped back on board again as soon as I got the opportunity. And that kind of led me into this opportunity with Rheia and leading the product side of the program about 4 or 5 years ago now.
Yeah, yeah. Well, Ipicus, and I've been fortunate enough to meet both of those guys, and that
Yeah.
they've been around since the '70s, and they've been part of housing innovation and finding solutions in the housing industry.
Right.
And a whole lot of studies through the years. So, I mean, there's a lot of background behind Ipicus and a lot of talent and a lot of knowledge because they've really looked at the future of construction for a long, long time. So, I think just that alone speaks volumes for where you're at and what you're doing. So let's kind of jump into Rheia, right?
Mm-hmm. Yeah.
Rheia is pretty innovative, a solution for what you guys and girls have pulled together for the industry. And I'm looking forward to jump into this. But first, I have to ask you, where's the name come from?
Well, Rheia is, in a roundabout way, the Greek name for the goddess of comfort. So, and you can, if you look it up and do some research, or if you're an expert in Greek mythology, you'll probably find all sorts of other definitions for it. But that's kind of what we latched onto. We thought it was interesting and a kind of a cool name.
Right.
I think in the Roman gods, it's spelled a little differently as well. So it depends on which preference you have. But yeah, I thought it was a nice, neat, short name that kind of captured the spirit of what we were trying to do.
Right. Well, you guys are going to have to make that part of your tags, online, the Greek goddess of comfort, and all of a sudden Rhea is going to pop up around the world. Love it. Love it.
Hopefully, yeah.
Let's kind of jump in. Can you give us an overview of what Rheia is and kind of why you and your team have decided this is something that the industry needed?
Yeah. So, fundamentally, Rheia is an engineered air distribution system that creates kind of real improvements for labor and productivity and design efficiency and comfort. So it covers a broad range of things for the home builder, for the contractor, the HVAC contractor, and for the homeowner. And it really comes out of the challenge of where the industry is and has been in the past. As you know, obviously from an innovation perspective and productivity perspective, the industry struggled. HVAC is the same. And we solve those problems in a way that really makes it simple and easy to understand and kind of minimizes the change management process that's required to put an HVAC system in a home and make it work efficiently and effectively and satisfy the customer's comfort needs. And all of that really came about from the work we did at Ibicus. Back then, we were doing several DOE research programs for the Department of Energy and for the Building America program, and saw a lot of opportunity to improve comfort and find different ways to do that. And Rheia kind of popped up out of that program and out of that process, which is what it's designed to do, essentially, is create new innovations and new opportunities. Yeah. And we took that on as an idea. Probably, it goes back easily 10 years now. So it's not a new idea from our perspective. We've been working hard on it for a long time. The Ibicus folks, spawned the idea, as I said, and kind of really brought it to life. And then Rheia has really turned it into a commercial solution. Yeah. And
Go ahead.
Yeah, and basically, it's all about solving problems, right? It's kind of what I was brought up to do and trained to do, really, in the industry and in design, is you're trying to solve problems. So what are the problems? The problems today are labor, obviously. There's very few new technicians coming into the HVAC industry. It's just they're short of new people. The population of people in the industry is getting older. People are retiring, and there's no new blood coming into the industry. And that alone is an opportunity in itself to make a system that's more efficient to put in. If we can put a system in a house that's quicker and easier to do, then a contractor can do it with the same team he has today and fulfill some of that demand. And demand is still increasing and is projected to increase, whereas the labor force is projected to decrease. So we're trying to fit that need. The other big problems really the industry is facing right now, codes and regulations, obviously, they're getting more stringent. It's required, it makes sense. Make more energy efficient homes, obviously, is something everybody needs. We all need that. But it puts a bigger burden on the home design and on the HVAC system. And the result of that is, it gets harder to do and it requires more effort to do, and there's not enough people to do it, quality will suffer, right? So we're trying to address all of those issues with our system and create something that's simple and easy to do that performs extremely well.
Yeah, for sure. So, I've been fortunate enough to have this sneak peek already, and you have created a system that helps address the labor issues, in the field and during the installation by simplifying the entire process, which I think is great. And I can't wait to jump into that. But you've also simplified it from a technology standpoint, which we're going to jump into as well, and how this whole system gets installed and gets up and running to provide perfect comfort, to each room of the house, so to speak.
Right. Yeah. So, that's kind of part of our strategy, and it's a kind of a model that I think is happening in the industry more and more. It's to take the idea of product design or product innovation and tie it also to a technology solution. So we brought the two things together in our system. So we have a very effective design process, and we actually teamed up with Rheia, who are the industry leader in HVAC design software, and combined that with our system and created a solution that allows us to take a design, install it in a house, and then measure and verify that what we've installed is exactly what was designed. And that's unique in the industry today. So that's quite difficult to do with a conventional system. It's with a conventional system, it's old technology. It's a lot of parts. It's making sure everything is installed and connected together, and that's difficult to do, and it's time consuming. You have to use duct and mastic. It's messy.
Right.
You have to do it often in the attic, where it's difficult and a difficult environment. It's dangerous from the contractor's perspective, and all of that combined together kind of forces the contractor, who's kind of stuck with the materials that they have to work with, to kind of improvise and create a system that works. And inevitably what happens is issues come up. The framing isn't exactly what was the plan, or there's some changes to the design, and they have to kind of make it up as they go along, and they do the best they can. But inevitably what you have is a house that generally has one or two rooms that are just not quite comfortable. I think probably everybody's has that situation. Why is that front bedroom above the garage just not quite the right? It just feels a little cold in the winter, or it's a little too hot in the summer. It's a very common problem, and that's related to this lack of connection between the design process and what's actually installed
on site. So you simplified this process. Let's kind of jump into what this solution is. I think a lot of people that are joining us right now are like, all right, so what I'm hearing is you simplified the process. You're making our homes more comfortable. You're helping us with our labor issues for installation. You're helping us with figuring out what is the right volume of air to go to each room. And I also heard that it doesn't sound like you need tape or mastic as well with this.
Nope.
And it's so I think we need to jump into it. It's a big
sure. Yeah. So let's uncover it. Let's defog this, what we're talking about here.
Sure.
So basically, what we've designed is fundamentally a home run system, just like PEX Plumbing did all those years ago, 25 years ago. They created a new way of thinking about how to distribute water. We've kind of come up with a new way of distributing air by using that same analogy of having a central manifold that then we connect ducts to, and all the ducts are the same diameter, so you don't have to think about how to reduce ducts as you move through the house, which gets quite complicated and mathematically quite difficult to figure it all out. Those ducts run to each room in the house, and basically, because we know in the design what the cooling and heating load is for a particular room, and we know how much air is going to go through a duct, we can just assign a number of ducts to a room to meet the airflow needs of that space. And it's as simple as that. It's essentially a whole bunch of ducts that run back to a central point right above the manifold, right above the air handler in a manifold, and that manifold distributes the air evenly throughout the house. And then there's a lot of, we can dive into some of the details, of course, but in principle, it's just making sure that each room has enough air, and we do that by having enough ducts in those particular locations.
Got it. So you're controlling the air by the amount of ducts. Why don't, if you want, do you want to jump to the product page and walk people through that?
How do we do that, right? So there's a lot of interesting engineering that's going on to happen.
So can understand.
So the duct itself, as I mentioned, is a 3-inch flexible duct. It's made here in the US. It's UL 181 rated, and it is an off-the-shelf product, so we don't have to worry about the performance of that. We connect that all together then with a series of plastic components. So rather than today you use sheet metal connectors or duct board to connect things together, we use an engineering thermoplastic. This is also a UL rated assembly and material, so we've covered ourselves from the code's perspective. But basically, we have a set of parts that are engineered and designed to perform as aerodynamically and as efficiently as possible. So when you use small ducts, you have more resistance, right? Obviously, if you're blowing air through a small straw versus a big straw, it's harder to do. So in order to make it work, we have to ensure that the ducts are installed correctly, stretched a reasonable amount. We've got some tolerances there. But when we connect it, when we need to go through a corner, through an elbow, for example, we have a series of parts, a couple of elbows and connectors, and a ferrule that screws into the duct and air seals itself. We snap fit those things together, and you have a corner that's very efficient, has very little loss. And anytime you're doing some calculations on the losses along a distance of duct, you have to take into account the corners, and they usually pan out as a certain amount of feet of duct. It's usually 4 times the distance or something like that. I'm sure the engineers will tell me exactly what that is, because I can never remember. But what we've done is we've designed it so that air goes around that corner very efficiently and very effectively. And similarly with the boots, and I think there's a couple there. If you scroll down a little bit, we might find that image. And there's the manifold and the duct. Let's scroll up, sorry. There's a sealing boot. Basically, same principle there. It's a plastic component that's fastened between the trusses in the ceiling, and we snap fit our elbow and our ferrule to that particular component as well. So from a labor perspective, you can imagine it's pretty simple. You take some duct, you screw in a ferrule. Now you've got an airtight connection. You snap fit an elbow or whatever you need to connect it to, and that's also an airtight connection, or let's say near airtight. Officially, can't really say perfectly airtight, because that depends on the pressure we're dealing with, but it's very close to airtight. And once you snap fitted those together, your assembly is done. So now I can move on to the next diffuser, the next connection. I don't have to worry about tape or mastic, and it makes it much, much simpler.
So with this design, what you're saying is, because the plastic can be engineered so precisely that it's just a tight fit straight out of the box, so to speak. It's a matter of snap and go.
Yeah, that's the beauty of injection molding components, right? We can make them extremely accurately to small thousandths of an inch, and we've designed it so that when those snap together, they actually friction fit together and hold in place. And that's what creates the airtight seal across all of the connections. And it's very repeatable, right? Injection molding, we can control the quality of that over time through the injection molding process, and you get an excellent result. And then you can build into that, because it's injection molding. You can design in clips for the hanger bars or fasteners to connect it to a wood structure. And we've also integrated the damper system into the diffuser itself, into the boot rather, at the end of the run. And we can do that because we don't lose any air leakage. We don't have any air leakage across the whole system. So we can control what comes out of the system at the end of the run or at the beginning of the run. It doesn't really matter to us. We chose to do it at the end because that's the easiest place to make an adjustment when we do the balancing process. Right. So inside each one of those boots is a little butterfly valve that you can click. There's 5 settings. And for the contractor or the rater to do their commissioning, it's a really simple, follow the app and set it to the setting number 1, 2, or 3, or 4, or 5, and it's ready to go.
So, all right, so let's go. I'm going to take a step back, because one thing you just said is an app. There's an app for this mechanical system. And we're going to jump into that. But let's go back to the diffuser box, the home run, how all of this starts and how this system works. If I'm a general contractor out there, or production builder, and I'm hiring my mechanical MEP contractor, whomever it is, let's talk about how this system incorporates into my homes.
Yeah. So, starting from that side, from a home builder's perspective, we use conventional equipment, air handlers and the condensers. So there's nothing to change there. We operate within the what's called the fan curve performance of a typical air handler, and we maintain a static pressure that's within the range that the manufacturer is happy with. And that was actually part of the development process. Early on, we actually did, we worked for a couple of years with Carrier, and they helped steer us in the right direction to make sure that it would perform to a particular band of range of static pressure. And that static pressure is important to the manufacturer, because if you exceed it in performance, you wear out the equipment much faster, and that probably even has a warranty issue as well. So we stay within that range, and that's what's unique to us versus a high velocity system. I think some people are thinking, oh, it's just another high velocity system. It's not. It's low velocity, and that makes all the difference.
Yeah. So, I mean, let's talk about that. So how is it, and so people understand, how is it not a high velocity system? Because it has all the same components in theory, as far as, duct diameter, things of that nature. You're looking at it a little bit differently, and it's not about having one or two runs to a room. It depends on how many that it calls for. Is that correct? And that's how you get out of that.
Right. Yeah. Exactly right. So the design tool in RightSoft, the plugin that we use, does the duct design based on the manual J calculations of how much heat and cooling load is needed, and that design process then determines how many ducts you're going to need to add into the house. So we can generate our bill of materials from that, which we can give to the contractor so they can place the order for components.
Right.
And that bit of information of this is the design and this is how much air should come out of each duct is then handed off to our app automatically. So when the rater goes in or the contractor goes in to commission the system, they pull up the app for that particular house, lot number 123, Elm Street. Okay, this is how this system should perform. They get their flow hood, and as they would measure today, put the flow hood on a diffuser. This is bedroom. This is master bedroom diffuser number 1. You need to have 35 CFM, so it will measure. And if it's above or below that, because there's some variances in how you install, it's never installed perfectly, we can adjust that damper accordingly and make sure it has the airflow that's designed. And we just do that one time through each particular diffuser in the house, and then the system is balanced. And then we have some safeguards there and some checks to make sure that it all performs correctly. And then the commissioning process is done. In the trials that we've done so far, it's a 20, 30-minute exercise versus a couple of hours today if somebody does it. In many cases, it's kind of skipped because it's a pain of a process to do. You have to go around, adjust some registers, go back, adjust other ones. And then inevitably, the homeowner goes and changes things anyway. So they end up tweaking those for their own good. And then they don't understand why they feel uncomfortable. Or they go down in the basement, and they have the big damper lever, summer winter thing, and that stuff just causes problems. So we've tried to get rid of all of that and make it much more streamlined.
Yeah, simpler. So there's a lot to unpack right there, and I'm going to jump into some of this stuff. But first, I want to just welcome everybody who's joining us. We have Nigel Watts on, VP of Products at Rheia, and we are talking about a new product that they are coming out with that is geared towards addressing labor issues, productivity issues, comfort levels in homes, so on and so forth. So if you're just joining us now, please hit that like and share. And Nigel, why don't we look at some of the comments and say hello to some of the people that are joining us? I see we got Eric Holtz from the University of Denver tuning in. So you got some higher scholars looking at you. Dr. Brett Munson is also tuning in. We got George Ryman. Good morning from Phoenix, Arizona, where we couldn't live without HVAC. Absolutely, AC in general, right?
About to find that out.
Yeah, for sure. Hey, David Graham. Good to see you. Good morning, gents. We have Etienne. Etienne is the CEO of SIGA North America joining us. So nice to see you, Etienne. Thanks for joining us this morning. Anthony Good, very interesting system. First found out through the Housing Innovation Alliance. Great to see you covering this and spreading the word, Dave. Well, thank you very much. Good. I appreciate you tuning in, Anthony. All right. John Gagley, do you have an insulated version? Now, I know we didn't get into this yet, but go ahead and answer that.
That's a good question. So one of our kind of core pillars or core philosophies of this system is to bring ducts into conditioned space. That's being driven obviously by the code, Title 24 codes in California, driven by the California Energy Commission. And that's going to move throughout the country eventually. And if you think about it, insulated ducts are required because you're outside of the conditioned space of the house. And in a lot of locations in the country, including Phoenix and California and some of Florida and other locations, the logic of putting a system in an attic, which isn't conditioned, which in the summer is maybe 150 degrees Fahrenheit, and then trying to cool a house with that equipment through ducts, the logic of that is kind of strange if you think about it. So our approach is to say, we're not going to do that. We're not putting our ducts outside of the conditioned space. The Rheia solution to that is to move them into the conditioned space. And how do you do that? You have to create some space to do that. But remember, we have a 3-inch duct that we're dealing with. So doing a block ceiling or a bulkhead somewhere is much easier. It's a much smaller structure that you have to deal with. And then if we're running in a wall, we can run in a 2x4 wall without any changes at all. There's no issues to running the ducts in a wall. So in theory, you could run insulated ducts with the system. There may be some cases where that's necessary if there's some challenges we have to get around. But we're promoting not to do that because it's easier and simpler and much more efficient. And that's where the codes are going to go anyway. Everybody is going to adopt those codes eventually. To make everything, it's just a waste of energy. I think I can't remember what the numbers are exactly, but you're throwing away 20-30% of the cooling energy that you've pumped into the ducts by having them in an attic. Even if they're insulated, it's still a challenge. A couple of other ways of dealing with that is to say, well, let's insulate the attic and leave all the equipment up there. That's fine. But look at the cost of that. Spray foaming an attic, spray foaming the trusses in an attic is expensive, and it's dangerous, and it's time consuming, and it's slower than our solution. Or deeply buried ducts. And if deeply buried ducts are done perfectly correctly, I think that's a solution too. But for us, I think it makes no sense given that we have a compact solution and we can hide those ducts where we need to.
Yeah, sure. I mean, it's a significant cost to insulate an attic, and depending on what time zone you're in, right? You're in Pittsburgh, I'm in New England. Mm-hmm. Insulating an attic is the real deal up, at least in a lot of the country, depending on what zone you're in. And it just makes sense. I mean, that's the whole idea of the system is it's able to be put in conditioned space during the construction process. Therefore, you don't even need to insulate the ductwork that you already have because it's already insulated within the conditioned space. So you're saving on two fronts, really.
Yeah, right. Exactly. It's kind of one of those things where you're like, oh yeah, why do I have my air conditioner in the attic?
Right.
If I want to service it or if I want to replace it, it becomes a serious problem to do that. So, Florida, for example, have moved out of that model. They still run the ducts in the attic, but at least they've moved the air handlers out. Right. But there's a change management process there for us as well. And we have to work through that with the builders and the contractors and help them understand ways to do that. And yes, there is some sacrifice of square footage in the living space. But, with a 3x3 foot air handler closet, it can be done. So it's a compromise in that sense, but so are the other solutions. And, the net result of a more comfortable home, a house that's built quicker, more productively, and with fewer callbacks because our system is a lot more predictable and is more airtight and more efficient. The chances are of callbacks, and we haven't proved this out yet, but chances are we're going to see a lot less callbacks with our system.
Yeah. So, and I think it's important to note, I mean, there was a lot of builder input on this. This was designed by, a lot of builders being involved in this entire process with IPCOs, right? In the process. And that's an important thing to note.
Yeah. And that's what IPCOs does, right? That's one of the unique characteristics is they can bring manufacturers and builders and contractors together and really understand what the problems are and really problem solve around those issues and generate solutions that make sense. And for us, during that process, in the earlier days, we built a pilot. We actually built a lab home, and then we built a pilot home to test out the system. Right. And we brought builders and contractors in. We had a local contractors here actually do the installations for us. We did installation trials to kind of prove it out. And hence our claim that, we think we can meet up to potentially 50% installation time improvement. A smaller house, more simple house might be 25%, but it's going to be somewhere in that range. And that's meaningful, right? That's meaningful to the builder who can, if he can close a house in a day sooner than before, that's great, right? From a financial perspective and bottom line perspective.
Right.
For the contractor, similarly, if I can do more with the same crew, or I can get my crews into more houses a week, that's a bottom line win for me too.
So you said something pretty significant: 25 to 50% time savings with the installation of your product, which means that you're moving everybody up in the schedule. Your plumbers, your trades, your sheetrock, everybody, right? Electricians, because everybody's kind of working around the HVAC systems.
Yeah, right. And that's a good point, because with a smaller system with small ducts, it's a bit more flexible too. So if there's a situation where you might want to run plumbing first before HVAC, which is today, you'd never do that. You can do that because we can still work around other obstacles. It's easier to route a lot of smaller ducts than figure out how to handle these massive trunks of 12 by 12 main trunk lines and flex duct. It's just harder to do.
Yeah, for sure. Well, listen, I want to start unpacking some of this stuff. Let's get back into the nitty gritty. Yeah. So here we've talked about the system coming from the manifold, right? And they're home runs. These are home run systems. It's not one trunk line with a bunch of other pipes or ducts coming off it that's sucking away the pressure of that particular main trunk line. Yeah. And it's not a high velocity, and it's controlled by an app. So, and we haven't even gotten into the productivity savings yet, other than the 25 to 50%. Yeah. So with that said, how do you go about getting this in your home? Let's talk about that. So does this retrofit with another mechanical system? Is this the whole heating and cooling system that you're supplying from the air handler on out? Walk us through there.
Yeah, that's a good question. So let's address retrofit first. Today, we're not in the retrofit market. That is, potentially part of our longer term strategy. Today, we're focused on production home builders, where the majority of the homes are built, and it allows us to focus from that perspective. So we can work with the home builders that we have as part of our investment group. And we're focusing on certain markets where we can have the biggest win as soon as possible in the quickest way. The solution we have right now is fundamentally the supply side. We're not touching the return side, but we do have a preferred return strategy, which is a central return solution, which most production home builders are moving towards anyway, because it's simpler and it performs better. And this gives us a kind of minimally viable product. That product is basically the supply side, ductwork, components, fittings, brackets that we need, and the manifold that the contractor builds in their shop. And that is the package that we sell today and position today. Moving forward, we'll look at other areas. The return system is an interesting area to look at. If we can optimize and componentize the return system, that will be a valuable addition to the product line, and it'll make it even simpler for the contractor to basically order up what they need for a particular house and put together a kit and take it to the job site.
Sure.
And that kit is interesting because if as most home builders will know, obviously, and contractors, if I'm putting a kit together for a house, let's say a 2,500 square foot house, typical 2-story home, wherever it is in the country, I'm going to need probably a 4x12 or 4x10 pallet to put all that on. It's bulky stuff. It's big. I may have pre-built the trunk in the shop beforehand. I've got the return system in there. I got components that are fairly big and bulky, and it fills up one of those. Fills up a pallet that big, with a cage around it, 4 foot high. For us, you can do that on a 4x4 pallet, even with the return system. If you're using a centralized return with a flex return, we have 3 or 4 or 5 boxes of duct that is supplied at 25-foot lengths, and we have a box or 2 of plastic components. Mm-hmm. We actually have a lot more single components than a conventional system, but they're all small. Right. They're all roughly 3 inches in diameter size. So we can package up a lot of product in a relatively small box. So from the contractor's perspective, that's I worry less about inventory in my shop. I don't have to worry about how much stock I have, and do I have every single component that's needed in a typical installation. And that can be hundreds of SKUs. For us, you just have a few shelves of the 12 SKUs that we're dealing with, and then I don't have to, when I'm picking that and selecting that material for a particular job and putting it on a pallet, you're much less likely to make a mistake and forget something, then have to go back later and go get it, or go back to the distributor to buy some more material. It just makes everything simpler and easier for them. They can run twice as many runs with a truck delivering pallets to the job site, kits to the job site. That's another efficiency that they can realize. So right. The basic fundamentals of the system, the home run, the small diameter duct, and small components, it kind of snowballs all the way through the delivery chain and makes everything easier for everyone.
Yeah, so 12 SKUs will get pretty much every house done.
Yeah.
And that's an inventory thing that they don't have to track from a mechanical contractor side. Even a supply house side, that makes tracking inventory all the way through the supply side too, if it wasn't a direct sale. And then also, putting this all together, 12 SKUs, well, that simplifies it. One, we've simplified the ordering process. We simplified the keeping inventory process. We don't need a bigger truck anymore, right, for all these things. But on the other side of this, the installation time, because of the snap together component, has been reduced. We're looking at a 25 to 50% savings. How do we decide, and how do we know, I guess is more the question, what do I need for my house? Here I am, I have my 2,000 square foot, home, right. 4 bedrooms, 3 bedrooms, whatever the case is. How do I know how to get comfort in my house? And I have a feeling you're going to tell me it's done through an app.
Well, it's the software side of the equation, right? So this is not just a product, a physical product. It's also a software solution. It's the blending of those two together, which is what really makes it unique. And that is the future of product development, especially in the home building industry, I think, as we look towards more connected homes and connected solutions, and connecting homes into communities, into the energy grid, and all the wonderful, great things that are going to come out of that. We similarly have that same philosophy. The design process is unique. We basically developed a series of algorithms to make the design process work. We've worked with, I said earlier, RightSoft, industry leader in HVAC design tools, and those tools are on every desktop of pretty much every HVAC contractor in the country, and also the design firms that do the work for the builders. And out of that kind of magic of algorithms, a duct design is created with the interface that they use. That is then the design for that particular house. So we can work the system a couple of different ways. We can do a worst case scenario design, but in reality, the best approach is to do house by house for each orientation and for each different derivative of the plan. So a plan that might have an add-on room or a sunroom or something like that. That data, that file, is then it captures the bill of materials. It captures the air pressure for each duct. It captures the static pressure of the system, the return pressure. It captures the airflow required for each duct, and that data is what we carry through to the commissioning app, to the end point. So why have an app at the end? Why have a tool at the end of the installation? Well, again, the beauty of knowing how this system should perform and exactly how many CFM should come out of each duct and out of each register. Having that at the end means we can check it. So the rater can take their flow hood, measure a particular diffuser in the house, check that against what the app says it should be, and then, as I said before, reach in, do a few clicks to adjust the damper if it needs to be adjusted to a different setting, and then that exact airflow will be very close to that airflow will be coming out of that duct. And as long as I do that for everyone in the house, then I've exactly met what the design intent was in the first place. And that is what's missing today, is that connection between the design intent and the actual performance that the system has when it's installed.